Now we are at the core part, the key part of business application, which is to maximize profit. So previously we talked about maximizing revenue, minimizing cost, but those are only partial of the problem. The key problem as a firm, as a for-profit firm, which takes up at least 80% of enterprises in the world, your key goal is to take any chance you can to elbow out, namely to maximize your profit, right? So here, just quickly review what are the components of profit. So here we have a positive part, which is your income, namely total revenue, and a negative part, which is the total cost. So then we're going to approach to this with the methods that we are pretty familiar with, the 4-step or namely 2-step method. The first 3 steps are the first order conditions, the solution for first order conditions. So we take the first order derivative profit as a function of Q, and the profit is noted as pi. And then we set pi prime Q equal to 0. That is actually the marginal profit equal to 0. And eventually we solve for Q so that Q star, so that pi prime Q equal to 0. So the first 3 steps are to solve for the first order conditions, right? And the last one to check the second order condition to make sure you're maximizing it. As you're maximizing, that means this is supposed to be a concave function. And namely, the second order derivative should be smaller than 0. Okay, now let's look at one question. So this is example 5, and this is the first solution. That's why I label this as A. So here we have a bunch of functions that we previously solved. So let me do a minor correction of the mistake. It's 20Q. Okay. So those are exactly the same function as we previously solved for maximizing revenue and minimizing costs. Okay, so now let's get to this. In this case, we are to, now it's example 5, okay, we are to maximize profit by choosing Q. So I would suggest that you always define a problem this way on the side of the paper so that you have a clear idea what you are supposed to do. So here, Q is a choice variable. That means as you're writing profit, you should also write a profit as a function of Q, right? So here we have P equals to 80 minus 2Q, and we have fixed cost equals to 50, variable cost equals to 2Q squared minus 20Q. Okay, so first, profit equals to 2 parts, the combination of 2 parts, total revenue minus total cost. So first you need to figure out what's the R. So total cost is just a summation of fixed cost and variable cost. That is 50 plus 2Q squared minus 20Q, right? And total revenue is price by quantity, where price is expressed as 80 minus 2Q by quantity. So it's 80Q minus 2Q squared. And then profit is total revenue minus total cost. That is 80Q minus 2Q squared. That is your total revenue minus total cost. That is 50 plus 2Q squared minus 20Q. Don't forget to add a parenthesis, especially when a minus sign is involved. Okay, so now we can expand this we can simplify this. So the result is 80q minus 2q squared minus 50 minus 2q squared plus 20q. Okay, so now we can put things in order. So we do the high power first. Minus 2q squared minus 2q squared. The result is minus 4q squared, right? 80q plus 20q, that is plus 100q minus 50. Right? So I would suggest after you calculating each term, just add a little on the line so that you know that you have already done this term. And here we need to deplete all the terms. So the result, the profit, is expressed as a function of Q, which as we previously discussed, right? And here is minus Q squared plus 100Q minus 50. So let's do the first order condition. Step 1. So pi prime Q equals to minus 4 by 2Q plus 100, which is minus 8Q plus 100. Okay, and here we want to solve for the solution of this equation. So that is minus Q equals to plus 100 equals to 0. So 100 equals to 8Q. Q star equals to 100 over 8, which is 25 over 2, 12.5. Okay, that's Q star. And then second order condition is pi double prime Q. That is, now we're working on this and take another derivative with respect to Q. The result is minus 8, smaller than 0. The function should have a slope of the tangent line that is decreasing in Q. So here it is concave, and we do have a max. Check. So when Q equals to 12.5, it could be million units, right? Profit is maximized. Okay. Put it officially. Maximized. So this is the traditional way of doing this. We are following the two-step or the four-step methods, right? We solve the first order condition, then we solve the second order condition. We check the second order condition to make sure the stationary point that you solve from your first order condition, this equation, is actually a maximum.